Welcome back, guys. This is the part 3 of equations and inequality systems, which is second degree inequality systems. And I have good news because this is the last part and also the last video of this unit. And I have a couple of examples here in this video. We will solve them together. So let's start. Okay. As I said, our topic is second degree inequality systems. So what are second degree inequality systems? A second degree inequality system consists of more than one inequalities in which at least one of them is a quadratic equation. So we have more than one inequality and at least one of them is a quadratic equation. Okay. Let's say I will show the method to solve this kind of questions. That's why again we have the inequality table here, but this is a little bit different than what you have seen on the previous video, because since we have more than one inequality, we are writing all of them, and usually we will solve two inequalities. The system will have only two inequalities in this video, and that's why I have written fx and gx. Think about them as equations, and we will find the solution set of the given inequality system. Let's say we have two quadratic functions fx and gx, as I said, which have the roots x1, x3 and x2, x4 respectively. So x1 and x3 are the roots of fx, and x2 and x4 are the roots of gx. Let's say I just made them up. This row doesn't need to be like this, doesn't necessarily have to be like this, but I just made it up to show you how to solve this kind of questions. In case these quadratic functions specify an inequality such as fx is greater than 0 and gx is smaller than 0, again I made this up to show you how to solve these questions, we should place them in an inequality table and find the intersection of the solution sets of these two functions. Let's say fx starts with a plus sign, and I will just fill this inequality table for both fx and gs. Plus, this is not a root of fx, that's why I am continuing as plus, and x3, there's a circle here, it is one of the roots of fx, that's why whenever I come to a root, the sign changes, that's why it becomes negative. Again negative, I don't have across to a root, and x1 is a root, that's why it changes to positive again. And let's say gx starts with a negative root, change sign, positive, no root, positive, stay positive, root become negative, and continue as negative. Okay. And we have said that fx is greater than 0. So we will take these actually two intervals, because this consists of only one interval since x4 is not a root of fx. These intervals, and include them in our solution set. Okay. Fx should be greater than 0, so I am including the plus signs when fx becomes positive, and also here. And what does it ask us? Gx is smaller than 0, so negative. We are asked to include the negative parts here and here, greater than x4. Okay. Now the second step is very important, and don't please mess it up. We will find the intersection of this solution set. Okay, this interval and this interval is the solution set of fx. Also, this interval and this interval is a solution set of gx. Now I have to find the intersection. So one of the intersection is here, as you can see, when on the interval from minus infinity to x1, fx is positive and gx is negative, just as I wanted. Here I don't include because fx is negative. Also I don't include here, and I don't include here because even though fx is positive, gx is also positive, but I want gx to be negative. And yes, this is our second interval to include in our solution set. Fx is positive, gx is negative, just as I wanted. So I can write my solution set like this: from minus infinity to x1. I don't include x1 because it says greater than 0. Union from x4 to plus infinity. Okay, let's start solving an example so that you understand it better. How many x integers are there that satisfies the inequality system given above? Okay, we have two inequalities here, and like all of the examples that we will solve, we first start by finding the roots and then creating an inequality table. Okay, let's start with the first inequality. X plus 4 over x minus 2 is greater than or equal to 0. What are the roots? The roots makes the numerator or the denominator equal to 0. That's why x plus 4 is equal to 0 and x is equal to minus 4. This is one of the roots. And x minus 2 is equal to 0, x is equal to 2. This is also one of our roots, but don't forget that x minus 2 is on the denominator. So when x is equal to 2, it makes the denominator 0. That's why it makes our equation undefined. That's why I will note it here to not forget undefined, and I will not never ever include it in my solution set. Okay, and this part, x squared minus 4x minus 5 smaller than or equal to 0, my second inequality. Now let's factor it out so we can find the roots. X, and I suppose this is minus 5 and plus 1 because their product is minus 5 and their sum is minus 4. So we have left with x minus 5 times x plus 1 is equal to 0. I am equalizing it to 0 to find the root. It is not equal to 0, but my aim is to find the roots. So x can be 5 and also x can be minus 1. Neither of them makes the equation undefined, so there we are okay with them. Okay, let's draw our inequality table. I am drawing two horizontal rows. I am writing x plus 4 over x minus 2 greater than or equal to 0 here, and below that x squared minus 4x minus 5 smaller than or equal to 0. Okay, what are my roots? My roots are minus 4, 2, 5 and minus 1. I will place them in my inequality table from smaller to the greater. So I am starting with minus 4, then minus 1, 2 and 5, and we have plus infinity and negative infinity here. I'm drawing my lines. Okay, now be careful which of these numbers are the root of my first inequality. We have found that the roots of the first inequality are minus 4 and 2. That's why I am drawing a circle only to these ones. Okay, and I have noted that when x is equal to 2, it makes the equation undefined. That's why I am drawing a second line. I mean, it's not necessary, but it helps you to not forget to not include 2 in our solution set. And the equation can be greater than or equal to 0. That's why I am filling minus 4 to indicate that I can't include it in my solution set for the first equation. Okay, the coefficient of x is positive here and also positive here. Positive over positive is positive. That's why I am starting with a plus. I am staying plus because 5 is not my root, but 2 is my root. That's why I am changing sign to negative. I stays negative and I come across the root. That's why it becomes positive again. And I will do the same for the second inequality. The coefficient of the x term with the greatest exponent is positive here, 1x squared plus 1. That's why I am starting with a plus, but I realized that I forgot to draw the circles to the roots. What are my roots? 5 and minus 1. These are my roots, and the equation can be smaller than or equal to 0. That's why we can fill this up. None of them make the equation undefined, so they are safe to include in our solution set. And as I said, I am starting with a plus sign here. I come to root, it becomes negative, it stays as negative. I come to root, it becomes positive and positive. Okay, now I will find the intersections. Okay, the first equation, inequality actually, should be greater than 0. That's why I will include here and also this part. It is greater than or equal to 0, so minus 4 is included, but 2 is not included because it makes the equation undefined. And the second one, it should be smaller than or equal to 0. That's why I will look for the negative parts here. Only this interval, and minus 1 and 5 is included. And let's write our solution set first. What is the intersection? There is no intersection here. I included this part on my first equation but not on my second. Here none of them are filled, crossed, and here also I don't include, not include, but here between 2 and 5 I included in my solution set. I am not including 2. If it didn't make the equation undefined, I would have included it, but it makes the first equation undefined. That's why I'm not including it. 2 to 5. Am I including 5? Yes. And why is that? First of all, in the first equation, when x is equal to 5, it is plus. Yes, there is a line in here, but it is not a root. It is again plus. And I am looking when this equation is greater than 0, so it's plus, positive. And I'm including 5 because the second equation, it makes the equation equal to 0, and it can be equal to 0. That's why I will include 5. And what does it ask? How many x integers are there that satisfies the inequality system given above? So actually, when x is an integer, my solution set becomes, I am not including 2, 3, 4, and 5. That's why there are exactly 3 x integer values that satisfies the given inequality system. So my answer is 3. Okay, example 2. What is the solution set of the given inequality system? Let's look at our inequalities. X squared minus 25 is smaller than or equal to 0, and the absolute value, oh, we have come across the absolute value. This is a new thing, but I will show that it is not that hard. Okay, x squared minus 25 is smaller than or equal to 0. We will start with that one. And okay, sorry for the interruption, let's move on. X squared minus 25 is smaller than or equal to 0, and let's first start by finding the roots. It is the difference of two squares. X minus 5 times x plus 5, let's say, is equal to 0. To find the roots, x is equal to 5 or x is equal to minus 5, and these are our roots. None of them makes the equation undefined, so I am including them. And let's continue on to the equation with the absolute value. Absolute value of x minus 2 is greater than 1. I will first find the root, and that's why equalize it to 0. I mean, x minus 2 minus 1 is equal to 0. I will act like it is equal to 0 to find the roots, and I will just add 1 to each of the sides. That's why it becomes absolute value of x minus 2 is equal to 1. And there are two possible ways. One of them is x minus 2 is equal to 1. That's why x is equal to 3, my first root. And the second possibility is that x minus 2 is actually equal to minus 1. That's why x is equal to 1. Okay, these are my roots. Now I will place them in the inequality table. I am drawing two horizontal lines. First, I'm writing x squared minus 25 is smaller than or equal to 0, and absolute value of x minus 2 is greater than 1. What are my roots? Minus 5, 5, 1, and 3. I am writing minus 5, 1, 3, and 5 from smaller to greater, drawing my lines and drawing the circles. Where am I drawing the circles? What are the roots of this inequality? They are 5 and minus 5, and I am including them because it says that it shall be smaller than or equal to 0. That's why I am filling the circles here. And the second one, we have found that it should be greater than, I mean, when we subtract 1 from each side, it should be greater than 0. And my roots are 1 and 3. I am not including them. And the coefficient of the x square here is positive. That's why I'm starting with a positive sign. Root become negative, not root stay negative, not root stay negative, and this is a root, that's why it becomes positive again. And this one starts with a plus, and even if you are not sure, just plug in a value like 6, I mean anything greater than 5, like 6. 6 minus 2 is 4. Absolute value of 4 is again 4. 4 is greater than 1. So it is true. I mean 4 minus 1 is 3. 3 is greater than 0. It's positive. That's why I'm starting with a positive value. I am staying positive. Then root, it becomes negative. Root, it becomes positive. And positive. Okay. And this equation should be smaller than or equal to 0. That's why the interval is here. Whereas this inequality should be greater than 0. I mean, if I subtract 1 from each side, it becomes absolute value of x minus 2 minus 1 is greater than 0. Since it's greater than 0, I'm looking for the parts where the equation is positive. And what are the intersections? The first intersection is here, and the second one is here. And my solution set is, am I including minus 5? Yes, because it makes it 0, and 0 is in our solution set. And here, when x is equal to minus 5, it is positive because this is not a root. That's why I'm including minus 5. But I don't include 1 because it makes the second equation equal to 0, and we are not looking for when it is greater than 0. So 1 is not included. Union from 3 is again not included for the same reason, and 5 is included. This is the solution set of the given example. Okay, example 3. What is the solution set of the given inequality system? We have again two inequalities, and let's first start by finding the roots. This is a little strange than we have seen previous, because we have this time an exponential function, which is 3 to the power of x. Now, the graph of 3 to the power of x is something like that. And if you realize that even though it doesn't matter how x is small, an exponential function is always and always positive. It can never be negative, even if x is like minus 1000 or 1 million, it can never be equal to 0 and also smaller than 0. That's why it doesn't intersect the x-axis at nowhere in the graph, and that's the reason it doesn't have a root. It doesn't become equal to 0. That's why this term doesn't have a root. That's why I can just neglect it and move on to the next parenthesis, x squared minus 1, and it can also of course be equal to 0. X squared minus 1 is equal to 0. X minus, this is the difference of the two squares. X minus 1 times x plus 1 is equal to 0. X is either 1 or minus 1. We have found two roots. Nice. Okay. And we have something on the denominator, x squared minus x plus 5. Now, I have noticed a strange thing about it, but I wonder if you have noticed it as well. Let's try to factorize it. Let's just try to find the root that makes the equation equal to 0. Okay, I can factor this out as x and 5. The only integer factors of 5 are 5 and 1. I can, since it is plus, it is either plus 5 plus 1 like this, or minus 5 minus 1. Their products are equal to plus 5, but none of their sum is equal to minus 1. I mean, the factor of 5 may be, it doesn't have to be an integer. It is something maybe 2 and 2.5, but we shall of course not try all of these values. If we have come across to such a equation and can't find the roots, just first find the discriminant and make sure that the discriminant is greater than 0, so it really has a root, that is real root. That's why we will just find the discriminant over here. What is discriminant equal to? B squared minus 4ac. Okay, what is b? It is the coefficient of the x term. I mean minus 1. Minus 1 squared is 1. Minus, we have this minus here, 4 times a. A is the coefficient of the x squared, so it is 1, times c. C is the constant term, which is 5. So we have 1 minus 20, which is minus 19. It is smaller than 0. That's why, since discriminant is smaller than 0, this term, this equation does not have a root. Since it doesn't have a root, we are not including it. It doesn't change our solution set. Let's move on to the second inequality, x squared minus 4x plus 5. Actually, I will give you a hint. There's the same thing for this inequality. Let's try to factorize it, and you will notice that you can't factorize it. Smaller than 0, x, and this is either plus 5 plus 1 and minus 5 minus 1. Their product is plus 5, but none of their products is minus 4. That's why after that point, if you have seen this, after that point you could try to find the discriminant and make sure it is greater than 0. If it is smaller than 0, then don't try it. It doesn't have any roots. Okay, let's find the discriminant of this equation here. B squared minus 4ac, as always. B is the coefficient of the x term, minus 4. Square of minus 4 is 16. Okay, minus 4ac, 4 times, what is a? The coefficient of x squared, which is 1, times c, the constant term, 5. We have 16 minus 4 times 5 is 20. That's why 16 minus 20, which is equal to minus 4, again smaller than 0. Since the discriminant is smaller than 0, this inequality also doesn't have a root, because when the discriminant is smaller than 0, since we are taking the square root of it, it becomes a complex number, since the inside of the square becomes negative. Okay, let's place them in our inequality table. Here I am writing the 3 to the x power x squared minus 1 over x squared minus x plus. You can, give this fx and gx to gain some extra time, but I'm just writing them to not make it any worse. Okay, x squared minus 4x plus 5 is smaller than 0. I got only two roots, 1 and minus 1. Remember that this doesn't have a root, this doesn't have a root, and this doesn't have a root. Only this term here has a root, minus 1 and 1. And this is positive, this is positive, this is positive. That's why it starts with a positive sign. Come to a root become negative, come to it become positive. 1 and minus 1 makes the numerator 0. It doesn't make the denominator 0. That's why it doesn't make the equation undefined. That's why I can fill these circles up to indicate that they are included in my solution set for the first inequality. And the second one, it doesn't have a root. That's why its sign doesn't change. And what is the coefficient of the x squared term? It is plus. That's why it is always plus, from plus infinity to minus infinity, always. And what am I looking for? When this equation is smaller than or equal to 0, here, and when this equation is smaller than 0, do you see any interval that this equation is smaller than 0? No. It is always and always positive. That's why there is no interval, no such interval that makes this equation smaller than 0. That's why our solution set is actually an empty set. Yes, it is that easier. I know. Example 4. How many x integers are there that satisfies the given inequality system? Okay, we have two inequalities. First, let's find the roots. I will rewrite this as x squared minus 2x plus 1 smaller than or equal to 0. We have 0 left in here. And I can factor this like minus 1 is actually square of x minus 1. Square of the difference. Okay, and that's why I have only one root. It is 1, and it is a double root because of that small 2 in here. There's an even exponent, and that's why it is a double root. Let's move on to the second inequality, and I will add x squared to both of the sides. Here becomes 0. It is greater than x squared minus 4x plus 4. It is also a square of something because x minus 2, it is actually 0 greater than or equal to the square of x minus 2. That's why I have only one root, and it is a double root. I will write it here so that I won't forget. Okay, now drawing the inequality table here. First we have x squared. I will not write it like this because I will have a 0 on one of my sides. These are exactly the same things, or this x squared minus 2x plus 1 smaller than or equal to 0. And I will write this. They are exactly the same thing, but this will make me see when it is negative, or what does it ask. Is it asking positive or the negative? It will make it easier to see that. 0 and greater than or equal to, which means we are looking for the negative intervals. X squared minus 4x plus 4. Okay, my roots are 1 and 2. Oh, I write minus 1, sorry, and 2. Okay, now the root of the first equation is 1, root of the second equation is 2, and they are double root, don't forget that. And are they included? Yes, they are included. Smaller than or equal to 0, greater than or equal to 0. That's why I am filling them. And neither of them make the equation undefined. That's why I am gonna include them in my solution set. Okay. The coefficient of x squared is plus. That's why I'm starting at plus. Plus double root. Don't change the sign. Stay as plus. Here the coefficient of the x squared is again plus. Double root, don't change the sign. Stay positive. And this is not a root. Stay positive again. Okay. And my intervals. The first inequality says that x squared minus 2x plus 1 should be smaller than or equal to 0. Do you see any negative intervals? No, I don't see it as well. And that's why only plus 1 is included in the solution set of the first inequality. I can write it like this. Only plus 1. Why am I writing minus 1? It's twice. Okay, never mind. The plus 1 is only the x integer that satisfies the first inequality. And if we look at the second one, it asks when x squared minus 4x plus 4 is smaller than or equal to 0. Again, it asks us the negative intervals, but we don't have any negative intervals. Instead, we have a number, only one integer, that makes the equation equal to 0, which can be included in our solution set. It is plus 2. Okay, the solution set of the first inequality is +1. The solution set of the second inequality is +2. What is the intersection? The intersection is, again, empty set. Yes, we have two examples which have the answer as empty set. Oh, it asks how many x integers are there that satisfy the given inequality system. Our answer is actually 0. Okay, example 5. The roots of the quadratic equation, an equation is given, are x1 and x2. If x1 square times x2 plus x1 times x2 square is smaller than or equal to 0, then how many integer values of m are there? Where is m? Oh, m is found here in this inequality. Actually, it's an equation, quadratic equation. We are given a really, it may seem complex. We are given x1 square times x2 plus x1 times x2 square. Now, I will rewrite it in such a way that it will be easier for you to see something. I'll write x1 times x1 times x2, same thing. I just separated the x1 square as x1 times x1, and here we have x1 times x2 times x2, and I want it to be smaller than or equal to 0. And did you notice any common elements on both of these terms? Yes, it is x1 times x2. These are common. So if I take it to the common parentheses, x1 times x2 times, we have an x1 left here. There's a plus between them. And we have an x2 left here. Okay, I want this to be smaller than or equal to 0. And you may think, how will I solve this? It's actually pretty easy. Do you remember how to find the product and sum of the roots? I will write it here so that it becomes easier for you. X, the sum of the roots, x1 plus x2, is equal to minus b over a. If you wonder what is the proof of that, you can go back to the third video of the first part. I explained it in every step. And the product of the roots, x1 times x2, is equal to c over a. What is b? B is the coefficient of the x term. What is a? A is the coefficient of the x square term. And what is c? C is the constant term. So I will rewrite it. x1 times x2. x1 times x2 is equal to, as I said, c over a. What is c? The constant term. What is my constant term? 2m minus 1. And a, the coefficient of the x square term. What is the coefficient of the x square term? It is actually 1. That's why this is simply equal to 2m minus 1. And what is the sum of the roots? Here we have an x1 plus x2. It is minus b over a. That's why this is minus and b. We are going to write b. What is b? B is all of this term minus b, m plus 4. These minuses will cancel each other over a. A is 1, as I said. That's why this is only m plus 4. Okay. Now let's go back to here. It is x1 times x2, which is equal to 2m minus 1, times x1 plus x2, which is equal to m plus 4. This shall be smaller than or equal to 0. If I distribute it, it is 2m squared plus 8m minus m minus 4 smaller than or equal to 0. 2m squared plus 7m minus 4. I will say that it is equal to 0 to find the roots. This is 2m and m. This is 4 and 1. There's a minus in front of 1. Okay, the product of 4 and minus 1 is minus 4. Okay, and if we add 2m times 4 and m times minus 1, it is 7m minus m, which is equal to 7m. So we have factorized it. It is actually 2m minus 1 times m plus 4 is equal to 0. Here m becomes 1 over 2 and here m becomes minus 4. If I place them in my inequality table, I have this complex equation. I will not write it again. And actually it is only the m1, but never mind. Minus 4 and 1 over 2, I have. These are my roots. Am I including them? Yes, they are smaller than or equal to 0. That's why I am including them. And the coefficient of the m squared term, it is plus. That's why I'm starting with a plus. Root become negative, root become positive. Where am I looking? When it is smaller than or equal to 0, when it's negative or equal to 0. That's why this interval is my solution. My solution set minus 4 and 1 over 2 are included. What does the question ask? This is the solution set of m, the m term, not x. And what does the question ask? How many integer values of m are there? M can be equal to minus 4, minus 3, minus 2, minus 1, and 0. 1 over 2 is not an integer. And that's why how many integer values are there? There are 5. The answer is 5. Let's move on to the last example, and it is really a special question. I mean, if you I will give you time to look at it and solve it on your own, because it's, I mean, if you solve this question, then okay, you have understood the inequality systems. Actually, yes, of course. And let's look at it. If the given inequality system has only one element in its solution set, then what are the possible values of r? Now you may see it as a very complex equation, because there are x squares, y squares, and also an r square. But if you move it to the coordinate system, then you will see that it is pretty much easier to solve. Okay, what does this equation seem to look like? Remember, I talked about it in the first video. If you see an equation like this, it is the equation of a circle. X plus some term square plus y plus some term square is equal to a constant. This is always the equation of a circle, and the values that makes this term and this term 0 are actually the center of the circle. So how do I make x plus 4 equal to 0? When x is minus 4, right? And how do I make y minus 3 equal to 0? When y is equal to 3. And that's why the point on the coordinate system minus 4, 3 is the center of my circle. So let's draw it in here. I think minus 4 and 3, it is something like that. It should be around here. And what does this 4 tell us? It is actually the square of the radius. So if the square of the radius is 4, then the radius is 2. And if I draw a circle here with the radius 2, I will draw it, it should be pass from here. I will draw it like this. I mean, it's not a perfect circle, but it works. This is only important. And the radius is 2. Don't forget that I am from here to here. For example, this length is equal to 2. This length is equal to 2. This length is equal to 2. This length, everywhere the radius is 2. And let's move on to the second equation. It is x squared plus y squared is equal to r squared. Okay. What is the center of this circle? I mean, what value of x makes this term 0? 0. I mean, if x is equal to 0, then here becomes 0. It is the same for the y term. If y is equal to 0, then here becomes 0. That's why the circle of the center of the second circle is 0 to 0. It is actually the origin. So here is my center. And what is my radius? My radius is square root of this term, and square root of square root of r square is equal to the absolute value of r, since these cancel each other, and I am left with absolute value of r. Okay, I don't know r, but I know something. What is it? This system has only one element in its solution set. One element. What does this mean? If the center is here and the circle is like, if the circle was too big, then it would be something like that, and it wouldn't even have a it wouldn't even have intersect the first circle and have an element in its solution set. But if it were something like that, then it would intersect the circle at 2 points. It will have 2 elements in its solution set. Having only one element in its solution set means it is tangent. It is tangent to our first square. That's why it should be something like that. Yes, something like that. Okay, and the radius is absolute value of r. For example, this length is absolute value of r. And what should I do? I found it. Aren't these two circles tangent to each other? If they are tangent to each other, when we connect when we draw circles to the point where they intersect, these lines are collinear. It's a rule. Okay, since these lines are collinear, I can now find the absolute value of r easily. The radius of the first square is, as I said, 2. And the radius of the second square is absolute value of r. And what is 2 plus absolute value of r equal to? We can find it easily. Did you notice the Pythagorean? Did you notice the right triangle here? This triangle. If I draw it again, like this, what this length is equal to here? It is equal to 4. And this length is equal to actually 3. And here is absolute value of r plus 2. Look at that. 2, 3, 4, 5 are the most famous Pythagorean triangle. That's why if this is 3 and this is 4, this term, this length must be equal to 5. And if absolute value of r plus 2 is equal to 5, then absolute value of r must be equal to 3, which means that r is equal to either minus 3 or it is equal to plus 3. The question asks us what are the possible values of r. That's why these are the 2 possible values of r. Okay, this is the last example in our video, and we have finished the second degree equations and inequalities, all of the units with this video. That's why see you later with the logarithm unit on 12th grade. Bye bye.